The universe has always intrigued scientists and onlookers over the centuries. Recent research has promoted a real revolution in the field of cosmology, revealing that the universe may not be as old as we thought. This theory is capable of changing our entire understanding of the universe. We are AstroGeeks, your channel of curiosities and astronomical news. To support us, don't forget to subscribe to the channel and leave that like to strengthen our community. According to a fascinating recent study published in the renowned scientific journal Royal Astronomical Society, the estimated age of our universe may be almost twice as old as we predicted. In 2021, the Big Bang Theory concordance model, known as Lambda-CDM, indicated that the universe was 13.797 billion years old. This model says that what governs the beginning and evolution of the universe would be the lambda, which is directly linked to dark energy, and the CDM, which means cold dark matter. That is, according to this model, the universe we know is, in a way, dominated and guided by dark energy and dark matter. As much as the Lambda-CDM model is the most plausible we know, there are still some scientists who are suspicious and do not fully accept the model, due to some factors that we still cannot explain. Have you heard of the Methuselah star? It is certainly one of the most curious things, without explanation, that helps scientists to refute the current model, because, according to calculations, the star Methuselah would be much older than the universe itself. It is also worth mentioning that there are studies that indicate that the entire calculation behind the age of Methuselah was based on uncertainties. But that star remains one of the main factors leading some scientists to believe that the universe is much older than we think. And thanks to the James Webb telescope, we have started the newest chapter in this story. Looking at galaxies closest to the Big Bang, what we currently believe to be 300 million years after the Big Bang. Some researchers have noted that these galaxies have a level of maturity and mass that would be associated with billions of years of cosmic evolution, not just 300 million years. Enter Rajendra Gupta, a physicist from the University of Ottawa, Canada, responsible for this new hypothesis. To reach this hypothesis, Gupta relied on a few theories, first using the tired light theory, which proposes that the redshift of light from distant galaxies is due to the gradual loss of energy by photons over vast cosmic distances, i.e., if photons lost energy over time through collisions with other particles on a regular basis, more distant objects would appear redder than closer ones. But due to conflicts in observations, this theory ended up being a little sidelined in astrophysics. However, Gupta found that by allowing this theory to mix with the idea of the expanding universe, it becomes possible to reinterpret the redshift as a hybrid phenomenon and not just due to expansion. However, that alone was not enough to move forward with his thesis, so Gupta introduced another very interesting theory to solve the problem. The so-called coupling constants. Coupling constants, a hypothesis created by Paul Dirac, are fundamental physical constants that govern the interaction of particles. According to Dirac, these constants may have varied over time, so it is possible that the time frame for the creation of the first galaxies observed by James Webb is extended from a few 100 million years to incredible billions of years, and this provides us with a more viable explanation for the advanced level of development and mass observed in these galaxies by James Webb. Combining Zwicky's tired light theory with Paul Dirac's theory of coupling constants, Gupta came to the conclusion that based on observations of those galaxies, they would not have been born 300 million years after the Big Bang, but tens of billions years ahead of schedule. Our newly developed model extends the time of galaxy formation by several billion years, making the universe 26.7 billion years old instead of the previously estimated 13.7 billion. This modification in the cosmological models to unravel the mystery of the small sizes of galaxies observed in the early universe, allowing much more precise observations, revealed Professor Gupta. However, it is important to emphasize that this is a promising theory and, therefore, scientists need to deepen their research and consider other elements, to understand more clearly whether our universe really can be twice as old as previous models suggest. The quest for cosmic knowledge continues. Our newly developed model extends the time of galaxy formation by several billion years, making the universe 26.7 billion years old instead of the previously estimated 13.7 billion. This modification in the cosmological model helps us to unravel the mystery of the small sizes of galaxies observed in the early universe, allowing much more precise observations, revealed Professor Gupta. And so, folks, we come to the end of yet another journey through the universe. So, is the universe really twice as old as we imagine? What do you think? Leave it in the comments, let's talk about it. Hope you enjoyed the video. If you enjoyed the content and want to continue exploring the fascinating world of astronomy, subscribe to our channel so you don't miss any new videos. And also don't forget to leave your like, because it helps our work a lot. Share with your friends to discuss it. Together, we can take knowledge and admiration for the universe further and further. See you in the next video.